Yeah. So here we go. So first time going live on what is CAD. So I just did a test run to see how everything was going, work it out, get my bearings all squared up, make sure. So let's put that up. Yeah, so let's hit this. Let's switch over right here. Let's kind of go through it. Um, I like this screen right here. So we're gonna share, present. We're gonna do share screen, and we're gonna do entire screen. We're gonna do screen number 2, turn on the audio. Yeah. So here we are. Here we are. So I'm just testing this out. All right. So while that's going, right, I'm gonna run this in the background.
Hello, everyone. Welcome back to What is CAD? I'm Winston, your guide to.
So I put that on mute. But so what we do on this channel is pretty much I'm more into designing. I like to design. I could do the tutorials and I could do a lot of that stuff, but every year it's the same thing. It's no growth in doing the tips and tricks. Yes, a lot of people get views, but I want to interact with the people. That's kind of my thing. I want to communicate, network, talk with people. So I like using software like AutoCAD, Revit, SolidWorks, Inventor. I've been doing a lot of stuff with Inventor. Um, and I want to learn more softwares as well too. I want to learn more CAD software. I use NX. It's okay. What's the other one? Katia, that's a high-end one. It's similar to SolidWorks. I messed around with it, but yeah, at the time I didn't have a powerful computer to test it out. So I want to get more into testing softwares and see which software is the best one to design it. My favorite so far is SolidWorks. SolidWorks is the best. I like Inventor. Well, I've grown to like Inventor. I wasn't one out the box with Inventor. But I could move around in Inventor pretty good now, you know? Once you understand it, it becomes good. There's some things it does better than SolidWorks, but um for me, I think SolidWorks, I could not work in SolidWorks for 3 to 4 months, and I could just jump back right into it. With Inventor, sometimes I got to stop and just think of what I'm doing. So that's sort of the things. It's like software like that where you got to stop and think of what you're doing. That and it's like Revit too. It's like I could not use. It's like I don't really use Revit as much. I understand how to use Revit, but it's like when I pick up Revit, I just jump back into the things because it's just like SolidWorks. So I just go in there and I start plugging away inside of Revit. So, and Revit is a real powerful software. Um, so what I try to do is connect with you guys, go over like 1 and 2. It's more for beginners. I like where people start off and they want to get into system. Like, oh, like this one. This is a good perfect one. Tablets. How do people feel about the new designs, being able to design on your tablet? Because I got an iPad, and that's one of the things I started doing. I started downloading one and two one and two applications to test it out. So I do a lot of testing, see how easy it is to design. And I'll be honest, sometimes it comes in pretty handy. So the ones that I downloaded so far was Unshape. Let me see if I could pull that up on the screen. I wish I could share my iPad screen. Okay, cool. Yeah, Unshape. Yeah. Let me open it up and I'll pull it up. So yeah, this one right here. So these guys Onshape. So I kind of like it. You could use it on your mobile phone. It's pretty cool. Um, that's one that I've been using a lot. And remember, I am not being sponsored by any one of these. And if you guys want to sponsor me, we could definitely do. My goal is to help people learn how to use CAD software. This was one of my passion growing up. It was just the generosity of people around me that when I was 14, someone gave me a computer. And once I had a computer, someone else gave me AutoCAD and it just took off from there. So, um, and I used to ask a lot of questions. You know, I'll go into places and I ask people questions. They thought my question were real intriguing because I was young, because I was really trying to learn the softwares. So Onshape is a pretty good one. Um, let's see if they have any videos on it. Learn more.
CAD is finally catching up to the rest of the world. The cloud reality is here and now. And only Onshape was built from the ground up with a true cloud-native approach. Introducing the Onshape Discovery Program. This program grants qualified designers access to our robust CAD and PDM system, free for up to 6 months. Through this program, you can try Onshape risk-free to see how Onshape can accelerate how you bring your innovative ideas to life. There are no gotchas, like needing a credit card to access the system, just instant access to a secure cloud environment. So why consider Onshape to power your next design idea? You get the power of a cloud-native system so you can design without limits from anywhere, at any time, on any device. You have access to built-in PDM that records every design change you make. There's only one source of truth, so you never have the headaches of file-based PDM systems like checked out and locked files, and the associated implementation and maintenance costs. Onshape leads the market in customer satisfaction, in part due to its unmatched stability, with no worries about data loss or corruption due to crashes. Onshape also empowers better collaboration by providing instant access to the correct version of your design via a secure link. You can do so with state.
So what I would ask here is if it's cloud-based, if the internet's down, how do you access the file? Because that's the only thing with cloud-based is how do you access your file? Because let's say, for example, one of the places that, such as Vault, right? If the internet is down, you can't access Vault, so your employees are not working. I've seen that many times where once the internet goes down, you could go on break. You can't access files, you can't check it in. You could continue to work, but if you're at a point where you're trying to replace, let's say, a bolt or a part into your assembly, the internet's not working, you're stuck. And that's kind of the same thing with cloud-based. And I'm sure they have a solution for this. But these are the questions, because when we look at Vault, that's one of the things. They're assuming that the internet is always going to be running. So those are the thing with cloud-based. You pretty much need to be in an environment where you always have power and you always have internet. And those are the two things. So on a big scale, it could affect you in a day when you really need it. Sometimes we take things for granted, like hoping that the power is going to be on, right? Hoping the internet is going to be on. And when you really need it the most, sometimes it's not there. I seen that most of this stuff kind of, I know in the islands, the internet, the power goes. Once the power goes, your internet is down. Once the internet's down, your internet's not working. So that's why I'm coming from that point of view when I'm talking. But it's it's pretty cool. The cloud-based stuff is pretty cool. And he also said the when he was talking about the checking in and out files, I would want to learn a little bit more about that area, because how do they maintain part control, and because once I see that feature, it's good, because if people are not affecting major, you could do whatever you want, but as long as it's not affecting the major part or the current part, we're good. And these are things we need to pay attention to, is with stuff like this, it may seem good in theory, but when you add like 20 people to the mix, it's a headache. But I haven't seen this software, but these are questions as I'm watching the video I'm pushing back on, because I want to know what they're talking about. To some people it may sound cool, but practical, let's using it in a practical or realistic way. How does it hold up with 20 people? And once again, like I'm saying, I don't know, but I would love to test it out and see how it works. Because the flow is similar to SolidWorks. That was one of the things that I do like about it. But let's see. Let's continue on right here.
Stakeholders inside or outside your organization. What's more, your team can comment, mark up, and even simultaneously edit the same models, unlocking new, modern, agile design processes. Onshape is easy to administer and requires no installation or specialty hardware. All you need is a web-accessible device, and you are guaranteed to be on the latest version of Onshape. So if you want to unleash your creativity and break free from the limitations of desktop CAD systems, sign up for the Onshape Discovery Program and design what's next.
And you see, even before he said all of that, it came down. It's web-based, so you're relying on the internet to always be working. I'm sure that they probably do have one that you could have it locally, so your file is stored locally. Vault have a similar situation where when you're working on it, the file is stored locally, and you could continue to work. And when you're done, you check it in. So I'm assuming they have something like that. But I would love to test it out. I've tried it. I've for the most part, I liked it. I haven't spent as much time to kind of give it a full review. And this is not a review. This was me just trying to get a better understanding of Onshape. Let's see, what's the price for Onshape? Hold on, I got to go back to that one. Let's see. Let's make this a little. Let's go back here. Pricing. So it's free to sign up, non-commercial. But he did say it's free for 6 months. I think he said it's free for 6 months. So unlimited public access CAD tool, real-time collaboration, version control, and mobile access online training. I kind of like the part where it says online training. I think that was the, like, software wise, solid. I believe SolidWorks killed it, because that's how they got a lot of people to learn the software. SolidWorks is one of the first, well, to me, one of the first softwares that you were able to pick it up, and it will teach you how to use SolidWorks. That's how I learned SolidWorks. I was self-taught. Most of these softwares that I use, I was self-taught. I just picked them up and I learned them. I got so proficient that I actually teach these classes. And it was basically all self-taught. I sat down, I didn't have any books. To get to the level of teaching, I had to start reading books, because I needed more information. And I was moving to the next level. You don't know, sometimes you don't know what you're doing. So, like, let's say you learn through trial and error. And once you get to a certain point, you start reading the books. You don't have to, because the book is explaining, hey, this button does this. this does this. And now you start reading the book, it's saving you a lot of time. Like AutoCAD, I have the reference book. They do one every year. I used to randomly just open the book like a phone book and just scroll through it, pick a command, learn it. And that's, but I've been doing AutoCAD since I was 14. So I've been using about 27 years. And it's evolving. I started when it was line commands. But this one, the Onshape, most of this is typical. This one is on the low end, but for a web base, they got to have like a standalone. I don't know, but I would love to test out this product more on a full-time basis. If they want to sponsor it, more than down to do it. But yeah, but this is one. Moving on to a next one, and I'll probably get into a little bit of SolidWorks. I had it up on the screen, just the first one. I'm just going through seeing what are some good CAD systems that's out there. Close this one. Because if I could share my screen, let's see. Let me see. Can I share my iPad screen? Well, since it's web-based, let's do this. Let's sign in because I think I got an account. 1 second. No, I don't have an account. Let's go back. They should have a demo because on the original one they have a better design, hassle-free PDM, okay, real-time collaboration, zero IT overhead, okay, startup, educational, students can get professional free of charge online collaboration with, oh, it says free right here. So as we go through this, right? So we're looking at Onshape and it says students and educator can get professional grade CAD free of charge, right? So what I'm gonna do is I'm gonna pull this off screen, set it up, create an account because I'm an educator. Let me just kind of pull this off here while that's thinking. So while I set this up, I'm gonna run this video.
And now the CAD
while I fill this out. So it's a live stream. So you guys got questions the same way too. You can put them in the comments or the emails in there. What is CAD at gmail.com. And it's CDs at the end as well. Even though the website is what is CAD. I believe I created an email before and I couldn't find the password.
for electrical engineers and $115,490 for electronics engineers. With a projected growth rate of 7% between 2020 and 2030.
So this is kind of what I do. Let me set this up with the
jobs in this field.
School email.
20,400 new jobs are expected. There you have it, the top 5 highest paying CAD jobs, from architects to electrical and electronics engineers. If you're considering a career in CAD, these fields offer exciting opportunities. Thank you for joining us today. If you want to learn more about CAD design, be sure to check out the links in the description below. Don't forget to like, subscribe, and share this video. Until next time, keep designing.
Welcome, FMS.
So let's bail out of this. I should have just put it on loop. I should have put it on a loop. So let's go back to here. Let's do
Unlocking the power of CAD design, a journey into the world of computer-aided design. Hello everyone, welcome back to What is CAD?
So while I'm setting this up, I'm just setting up the, what you call it, setting up the
Unlocking the power of CAD design, a journey.
I'm setting up the Onshape for education, and see if I could get it free. and that way I could do a demonstration of it. So there's already, so yeah, it seemed like I already created an account because it's telling me I got one. So let's sign in. Okay, let's see. On shape. Okay, yeah. I haven't seen you in a while. Say, okay. So I'm going through my emails. That's what I'm actually reading right here. Our team Onshape user, the goal is to successfully use Onshape. Let's see. Let's see. So, all right, cool. I'll open it twice. I got to remember my login for Onshape then. Can't remember it. All right, so let me run that
Into
while
the world of
I
computer-aided design. Hello everyone, welcome back to What is CAD? I'm Winston, your guide to all things related to computer-aided design. In this video, we will explore the basics of CAD design and how it shapes the world around us. So let's embark on this captivating journey together. The basics of CAD design. To put it simply, CAD design is like a digital tool that helps engineers and designers create and improve things using computers. It lets them make detailed 2D or 3D models with great accuracy and speed. CAD expert. CAD design lets us transform our ideas into virtual prototypes. It's like a special workspace where we can see and test our designs before actually making them in real life. Applications of CAD design. CAD design is used in many different industries, from buildings and cars to airplanes and everyday products. Let's see how it helps in each of these areas. Architect. Architects use CAD design to create detailed 3D models of buildings. It helps us see what they will look like and make changes easily before starting construction. Automotive engineer.
Okay.
For cars, CAD design helps engineers
Reset
make and test different
password.
parts on the computer. This saves time and money by avoiding mistakes and making sure everything fits together properly. Aerospace engineer. In the aerospace industry, CAD design is essential for making complex airplane parts. It helps us design efficient and safe structures, and it also lets us simulate how the plane will perform. Product designer. CAD design is a game changer for product designers. It allows us to quickly try out different ideas, improve functionality, and make products that look great. The future of CAD design? As technology keeps advancing, CAD design is also getting better and more exciting. New innovations are on the horizon that will make designing even easier and more creative. Technology expert. In the future, CAD design will use artificial intelligence and virtual reality. This means computers will help us come up with new ideas and let us experience our designs in amazing virtual worlds. And there you have it, a glimpse into the captivating world of CAD design. From creating virtual prototypes to shaping buildings, cars, planes, and products, CAD design is an incredible tool. I hope this video has sparked your curiosity and made you appreciate the power of CAD design. Thank you for joining us today.
All right.
If you want to learn more about CAD design, be sure to check out the links in the description below. Don't forget to like, subscribe, and share this video. Until next time, keep designing.
So that was that one. So I think I'm almost done. I got it here. I got it there. Got it there. So there we go. So let's pull this up on the screen for the good folks. Oh, so this was the one I was testing out. So I have it on my so you see, when you test stuff out and you challenge it, it works. So here is what we've been asking for to test this one out. So what's new on Onshape? So let's go click here, see what's new on Onshape. Proof it. Improvements in Onshape. Okay. It's 24. Let's watch 1 and 2 videos. Then we get into it. I want to see
parts made of flexible materials can exist in an assembly.
So, and all I did was I created a student account. I would definitely look into what considers you to be a student and go that route so you could test it out. I am an educator, so that's one of the good things that I've used to learn to test out software. So once again, I'm not being paid to review this. This is what I do on a regular. I go in and I open software and I test it out. How is it to create a certain part? What makes it easy? The flow, how does it work? One of the key things that I also look for is a program could be really good in creating a part, but what I need from a program is that detail drawing. I need my detail drawing to be on point. If you just give me a part, let's say if I'm 3D printing, it doesn't matter. Or if I'm doing something where a detailed drawing kind of goes out the window at that point. But I shouldn't say goes out the window. You're gonna have some little refinements as you go along. But for production floor, high-end production floor, you need a drawing. You need cut lengths, you need people, it's going to be different people creating one part, and it's not like everyone knows what it's supposed to be. So a detailed drawing needs to clearly articulate what are you doing and how it's going to be created and the requirements it should be made to. So a detailed drawing. So even if a software is good at making you or helping you to create a part, there's also that flip side where it needs to be able to clearly detail what you're trying to make. It's like dimensions, notes, hatch. It got to be clearly and easy to use so you could provided to the production floor, provided to the machinist, provided to your external or internal customer at that point. So that's one of the things I really wanted to make sure that um, even though it's easy to design, I got to definitely check and see, do they have a detailed drawing section to this? And I'm treating it like any other software when I'm going through. I'm just breaking it down, going through and see what they offer and how is it stack up. So that's pretty much what I'm doing right now.
In multiple states. Parts such as rubber seals, retaining rings, belts, and springs. Configuring each part with optional inputs is the easiest way to do this. However, Onshape treats each configuration as a separate part. In the example of the spring, it is the same spring, but it's called out twice in the BOM, even though it has the same part number. If this assembly was released, the BOM would be incorrect. To make things worse, parts like springs may need to be shown in different positions, which may generate even more configurations and more incorrect BOMs. Now, configuration inputs can be ignored by BOMs and release management.
So as they're talking, they're answering my question because I was just kind of explaining what I was looking for. So the detailed drawing is also part of the bill of material. Once you start creating a assembly, all the components that are in that assembly is called a bill of material. So that's what they're talking about. If you're creating a car is going to have four wheels. So on the bomb, it should have four wheels, that's an assembly, but a wheel is an assembly of other components, the tire, the rubber, and all that stuff, and how much components need to be there. So that's what he's talking about, the bomb right here.
A typical compression spring is defined by its outside diameter, wire diameter, number of turns, and free length. An extra input has been added which controls which faces to measure from the assembly context. That configuration input.
I kind of like that. I haven't used it yet, but you see this feature that they have where you cut the spring right here? That comes in so handy. Creating a spring and trying to cut it. The headaches back in the days, but the more technology grows, the more they make it easier to create what you're looking for. But yeah, creating a helix back in the day in a CAD software, crash. If you didn't want to work back in the days, and you wanted to kind of get out early, you just create a helix. You create a helix in the CAD software, and it would just crash it. Oh, my computer crashed. But um, those were some stuff that I noticed when I was designing. Like, yeah, we need a helix and screws. Like, nah, we'll do a cosmetic helix, or well, these were for more threads. You do a cosmetic because back in the days, a computer couldn't handle the processing to create a helix.
Can now be ignored by clicking on the three-dot menu and selecting Exclude from Properties. An icon indicates that the input is excluded in all the.
So this is pretty good. I just wanted to see what else they have. Improving bench. Oh, I gotta look into see detailed drawings. This one is midpoints, assemblies. Oh, you see, this is what I'm interested. See, I understand. Yes, softwares are good at helping you create, but I want to know how is it when you get to the detailing portion. If that detailing portion is good.
To establish a datum axis on a feature such as a hole, there are a number of ways to place the datum symbol. On the hole itself, on the feature control frame for the hole, which adds it to the dimension group, and now the datum symbol can be attached directly to the diameter dimensions leader line, either on the elbow or the leader itself. Dragging the dimension group will keep the datum symbol in its relative position along the leader. This also applies to radial dimensions as well, to follow the correct drawing standards.
Nice. So this is good. This is good. It didn't get too much into detail. So this is text. Let's
Dimensions with additional text above, below, or to the left or right, center justify by default.
Nice.
This behavior can now be changed with a new drawing property for text justification. You can set the default to left, to right, or to automatic.
Nice.
This last option controls the justification based on where the text is in relation to the extension lines. So if you drag it to the middle, it is center justified, and if you drag it to the left, it is right justified. This of course can be overridden for individual dimensions using the Styles panel.
Okay. So this is what I want to get into is see right here. This is what I'm talking about right here. Because a lot of people, when they come to mechanical engineering, they think all of it is just designing a part. So yes, an engineer is going to do all the heavy lifting, going to use his brain. He's going to go in and he's going to calculate how everything works down to the detail, clearance, and all that stuff. That's some people. If you're in a big company, most of that work would be passed down to the drafter. The drafters create it. But when the detail drawing goes back up to the engineer, he needs to make sure that everything is accounted for. So either way, if the drafter made it or he makes it, it got to be clear, right? Because sometimes all it takes is just something being off by a thousandths or whatever the case may be, depending on what industry. Let me preface it that, right? Because aerospace, boy, they got some tight tolerance. Yeah, aerospace, they got some tight tolerance. But just if you were just working in a regular shop where tolerance is not big, because I've worked in both aerospace and mom and pop shop, and or even some companies, they don't use tolerance. They understand what they're looking for, but their tolerance is not super. They're not basically heavy tolerance heavy. But this is what I'm looking for here is how the part is going to be detailed. So the detail drawing of the part. And for me, I would definitely say this is where most CAD designers make their money. Most people think it's creating a part. It's easy. Most people could create the part, right? Me and you could create the same part, but we do it totally different. One might be more streamlined, one might be more functional for editing. You could create a part, but it's hard to manipulate or make corrections to that part, and the next person could create a part with functionality, and it has the ability to be changed on a whim, right? Stuff like that. So a dynamic part too. So that's the next thing. You could create a part or you could create a dynamic part. And a dynamic part is, all right, if you put in all the mats and the ratios, you could calculate ratios to make sure, hey, every time this goes an inch, this needs to be half an inch, stuff like that. I've seen some people who, those people are smart. They put a lot of thinking, like pre-thinking, into designing a part. So when you go to edit it, you just edit like the length and everything adjusts accordingly. And yeah. So once you start using dynamic designs and stuff like that, that's a different level. But I'm trying to keep it simple. But overall, just I want to get into this part. This is a truck design. Yeah, so I'm gonna go ahead and play with it. I want to make sure. Let's see. First, I gotta design it, but even before I design it, I want to make sure the details are on, and I'm seeing what so I'm liking what I'm seeing so far. Um, let's see, done. You go to owned by, created by me. So let's go to create. And so what I would do when it comes to this point is I watch some videos. I'll like, let's say this is a brand new software. I have it for my iPad as well. Um, and once in a while, I'll just kind of use it and do it around. But if I fully want to get into this software, which I'm going to be doing, I want to test it out, right? Uh, I'm going to watch a little YouTube videos, get started. So create a document. So let's see this one. Let's open. I was trying to create a new one. Create. It says document folder, label part. So let's see here. Test. I want to know if I created this. Okay. So any CAD software is easy to learn. Once you understand the planes, you have right, front, and top, right? Where do you want to create the part? Normally I just look around my room and pick up stuff. You just kind of look at the plane, right? And that's what makes it three-dimensional. You have right, front, and top, right? So let me delete this. Can I? Can I delete it? Can I click on it and delete it? So this is the design tree. This is telling you how they created it. I want to delete it. All right, so I can build off of this. So let's go here. I want to select that plane. So go home. This is to rotate. This is to pan. This is to zoom in. Section view, properties, uh, leave comments, where used. This is pretty cool. So once you create a part, it tells you where this part is used. So let's say that we're talking about that spring. So if you have a standard spring that fits in all your components, every type of product that you use, it would tell you, all right, this spring is using all these products. So you just don't go in there and change that spring, because it's going to affect your whole product line. So you got to be able to know where it's used, so you don't affect affect a product line. So what I'm trying to do right now is, let's go. This is test. I want to go back home. Defaults. click on the plane, go here. It says hide show. So this is to hide the planes. I need to know how to create the part. And obviously, guys, this is my first time using it. So I'm fumbling around the same way on shape. I want to create a part from scratch. Create document. Okay, I had to go to document. So see, it's different. They call it a document. So we're going to call it wins test. So I was looking for a part, you know. Give me 1 second.